Hello students, in this lecture we will discuss about algebra of logic. In this algebra we need to discuss about some rules in logic which are useful us to simplify the circuit, switching circuit in logic, or to simplify larger statements into smaller statements. Means we have to reduce the statement given statement pattern. The property, you can say algebra in logic, we have the first property is associative law. Which law? Associative law. Let's see what is associative law. Here, if we have three statements, P, Q, and R, simple statements, the associative law we can define like this: P and Q and R logically equivalent to P and Q and R. Let us see, please. Here we have two symbols, and here also and. But in LHS, this bracket is given to Q and R, but in RHS, this bracket is given to P and Q. It means the law stating that when we have three statements, P, Q, and R, you can take ending of any two first and then after other. It means that as in LHS given, Q and R first we have taken ending, it means conjunction, and after getting the conjunction of this, we are taking the conjunction with P. The meaning of this is same as if someone take P and Q first and then R. Okay. Similarly, this law is true for R also. P or Q or R logically equivalent to P or Q or R. Okay. Then next, law number second, it is identity law. Identity law. Please see what is identity law. Keep in your mind that if we have any statement supposed to be P, and if we take ending of this P with true, the answer is true, you can check. And secondly, if we take ORing of this P with fallacy and a false, the answer is P. You can check it. As you know, P, we have P and T. Okay. For P, there are two possibilities, and for T, we have to fix the possibilities fixed. And if you take an ending, T and T, we know it is T, F and T, we know F, and it look like as P, we are getting the same TF. Got it? We are getting same TF means P. So we can say here P and T, for any P, its answer is P. Okay, for any P, Q, whatever, if someone is taking ending with this T, the answer is definitely P. Keep in your mind. Instead of this P, if someone taken Q and T is there, at that time we can write here also Q. Why it is? It is not depends. Oh, it is true for P only. It is true for Q only. No, it is true for R also. R and T also are. Like this, you know, in mathematics we have already studied 3 1s are 3, 4 1s are 4. It means no effect of 1 on 3, no effect of 1 on 4. Like this, no effect of any identity matrix on A. See here, this I is known as identity, 1 is known as identity, this 1 is known as identity, this T is known as identity, this T is known as identity. Similarly, here, this T and F are identity element, and this property, this law is known as identity law. Number third, complement law. Number third, complement law. Let us see, please, what is complement law. When they nullify each other, when they cancel each other, we can say complement. Okay. Or if you combine them, we get whole. That is complement. Like this here. What about this complement law in logic? P and negation P, they cancels each other. There are nothing in between them. P and negation Q is fallacy. You can check. Suppose that we have P and negation P. Okay. Possibilities of P are TF, and therefore negation P's possibility will be definitely FT. And if you take their ending, you know, if at least one F, answer is F. So answer is F for both the cases. So we can say P and negation P is F. Number two, like this, P or negation P is also F. Oh no, sorry, it is true. P or if you take or, the answer is true. P or negation, P is true. Okay. Next, number four. Number four. After this, we have one simple law, that is commutative law. Commutative law. What is commutative law? First, I'm writing here, and then after we will discuss about it. P and Q and P both have same meaning. P or Q and Q or P both have same meaning. As you know, 5 plus 3 is 3 plus 5. In addition is commutative, but subtraction is not commutative. You know. Okay. Just say plus is commutative. Like this, into also commutative. 5 3 are 3 5 are both are equal. Like this, P and Q and P or Q or P both have same meaning. This is law number 4. Next, number 5. Law number 5. This fifth law is again very interesting law. That is distributive law. That is distributive law. Number 5, distributive law. Here also we have to take the 3 atomic statements to define this law. Distributive law. We have suppose P, Q, and R 3 atomic statements. Then distributive law can be defined as number 1. P and Q or R is logically equivalent to P and Q or P and R. Let us see. Here and here or. Both the symbols are different reverse symbols. And we can say distribute or, and we can distribute like P and Q or P and R. We can remember reversely. If we have P and there, we can take that P and common, and then after taking P and common, what will be in bracket? That is Q or R in bracket. So you have to learn laws in both ways. LHS to RS, RHS to LHS both. Okay. Now the second law, its dual is and is distributive over or here, but second we can say or is distributive over and, or is distributive over and. Here Q and R logically equivalent to P or Q and P or R. Got it? This is distributive law. It is same as the multiplication, distribute, or addition. You have studied. If x into y plus z is there, and you can write x y plus x z. Okay. As you know, this dot or into is distributive over y and or addition, and we get x into y plus x into z. Like this, P and Q or C and R. P or Q and P or R. We get. Okay. This is distributive law, which is very useful and interesting and very easy. Okay. Now next number 6th law, number 6, 6th law. Please see the 6th law after distributive. It is idempotent law. Idempotent law. Potent means times and idempotent means same. Idem is same and potent means times. If you take any same statement so many times, the effect is like the same statement. That is idempotent law. Let us see, please. Number first, P and P effect, P only, P and P same statements writing so many times, no effect, meaning is same as the one statement. Why we have to say the same statement, repeating like this. Bombay is capital of India, Bombay is capital of India, and Bombay is capital of India, and Bombay is capital. No, how many times you are saying Bombay is capital of India? So at last meaning is same, Bombay is capital of India. So we can say here P and P is P. Therefore, similarly, P or P also P. It is again important law. The law is idempotent law. Now next law is number 7, boundedness law. Boundedness law. This law is like 5 zeros are we get 0 like this, true and false as an answer in this. So we can write it is exactly opposite of this identity law. Here we have P instead of this, and if someone taken or, answer is not P here, answer is T. You can check with the help of cases in truth table. Then again, instead of this or, if someone taken and F is here, the answer is F at a time. Answer we are getting T and F converting this P to P in its itself. So at that time we can say it is boundedness law, but T and F are deleting, cancelling. At that time we can say the law is identity law. Both are nearly same. Okay, but meaning are totally different. Looking same only. Number 8. After boundedness law, we have one interesting law, that is absorption law. Absorption law. All are here. We are saying laws because we are writing here twice laws. We can say. And again, if you observe, they are duals of each other. They are duals of each other. You can observe carefully. Now let us see what is absorption law. Absorption law. And this, if P is here and sign is and this P is again repeating inside the bracket, and if we have any member, any statement here, as this P is repeating inside the bracket and this symbol is reversing, the answer is P. Similarly for or in case it is true, so P and Q, any member with in place of Q is there, no effect, answer is same P. It means if someone is repeating inside the bracket and connected with the other with the reverse sign at a time, answer is P. This is absorption law, again important and useful law. After this 8 number absorption law, we have next 9th number is law number 9. It is Demorgans law. Demorgans law. We have studied this in set theory also. Demorgans laws. Let us see which are the Demorgans laws. During the taking negation of a conjunction and disjunction, we use this law, which is very useful law to find the negation of compound statement. Okay, this is number first. De Morgan, negation of the bracket P and Q, it can be written as negation P or negation Q. Second one, negation of P or Q is there, then we can write negation P and negation Q. This is 9th one, distributive law. 9th one, distributive law. Now the 10th one is, it is important and easy. De Morgan law is easy. Now 10th law is inhalation property. Inhalation property. Inhalation law. This is only law, not laws. Negation of negation something. Negation cancel out. Answer is P. This is inhalation property. Now next one, 11th property. It is very easy property. 11th one is conditional law. Conditional law. Let us see please, which is the conditional law. Again, important to solve multiple choice question. This law is helpful. First one, this is the meaning of negation. We can write negation in terms of oring, means disjunction. Write down the negation of first and then take or between them and write down the second member same. So negation P or Q is here. You can say this P is hypothesis and this Q is conclusion. Here the meaning is you have to negate the hypothesis and you have to keep the conclusion as it is, and in between them you have to write oring. This is the meaning of implication. It means conditional. This is law and very important to keep in your mind. Now next law is P implication Q is logically equivalent to the biconditional. So no, not biconditional. You can say it's contrapositive. Negation Q, implication negation P, contrapositive. Conditional is equivalent to contrapositive like this. Converse is equivalent to inverse. Converse is equivalent to inverse. No doubt at all. It is the contrapositive of this converse. Okay. This is conditional law. And now the next one, number 12th is biconditional law. Biconditional law. Biconditional law. Let us see please, what is biconditional law? Okay. Here also the meaning of biconditional in the first statement, P double implication Q is logically equivalent to P implication Q. The meaning and Q implication P. The meaning is P is hypothesis conclusion, and then Q becomes hypothesis and P becomes conclusion. And here both are hypothesis as well as conclusion. One time it and one time other. So this is the meaning. P implies Q as well as Q implies P. This is the meaning of biconditional. The same we can write with the help of conjunction. Using above law, a conditional law, P implication Q like this. Here we can use negation P or Q and negation Q or P This is by conditional second statement I written. It is useful you to solve multiple choice questions to identify the equivalent statement. Number three, again I am giving you only for you for solving multiple choice question. Negation of P double implication Q is logically equivalent to P double implication negation Q. We can check this again. Number four, negation of P double implication Q is negation P logically equivalent to Q. All about these 12 law, which are very useful law, which are required you to simplify the statement part, larger statement pattern, and to simplify the larger circuit. So thank you very much for watching this, and I hope you will understand. If you have any doubt, you can ask me. I have given, I think, my phone number there. You can ask me, no problem. I'm ready for you every time. Thank you very much. Bye.